Hi everyone, welcome to this chemistry class on chemical bonding. This is a very important topic because chemical bonding is used in many different chapters. The concept of chemical bonding, how the bonds form, how the atoms form chemical bonds, very important topic, and I'm going to make it absolutely easy and crystal clear for you. So let's get started. And before we begin, I just want to say that do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and please do share it with your friends. So just like we have a lot of friends, right? We form friendship bonds with our friends, and you know, friends always help us. So why do we form these friendship bonds? Because friends are there for life. In times of need, the friends help us. We enjoy, socialize with them. So life is great with friends. Similarly, we are going to see why do the atom form these chemical bonds. So you're going to become the James Bond of chemical bonding by the end of this video. So let's get started. So chemical bonds. So just like we form friendship bonds, atoms form these chemical bonds. So what you see over here, which is marked with these lines, these are basically chemical bonds. So these atoms, individual atoms, they tend to combine with each other. They form these bonds and they form molecules of compounds. But the question is why? So sometimes atom combine with itself to form molecules of elements, or in this example you can see here, these are molecules of compounds. But the question is why? What do you guys think? So that's right, the atoms form chemical bonds with other atoms to gain stability, right? It is just like, you know, with friends we have a stable life, or with good relationships we have a stable life. Same way here, atoms that need stability form bonds with other atoms. And these, what are these chemical bonds? Do they actually exist like this? Are there some, you know, sticks or lines joining these? No, this is just a representation. What is it representing? Chemical bond, these lines are representing a force of attraction between these atoms. Because if this force of attraction was not there, this molecule would have just broken down. If molecules break down, you and I or the whole world will break down. So what we are representing here is the force of attraction between these atoms, and they are doing it for their stability. So here's an example of what stability means. Have you guys played this Jenga game? I think it's one of the favorite games, very popular game with these wooden blocks. So here you can see this Jenga tower, as we call it. Does this look stable or this one? So clearly you can see this one looks dangerous. It looks like it's going to fall. It's on this block. So this is an unstable Jenga tower. And when you rearrange the blocks like this, it becomes stable. So here we have a stable Jenga tower. So same way atoms are doing this. Many of the atoms, or most of the atoms except, you know, for the noble gases, inert gases are unstable. So they are forming bonds for stability. So let's take a look at these atoms here and let's understand what is stability. So you can see I've put two atoms over here. Can you guys tell me which atom is stable? Even though you may not know what is the atom. Is it, you know, hydrogen, oxygen, carbon, or what atom is it? But just based on how the electrons are arranged, that is the electronic configuration, we can tell which atom is stable. It's very simple. So first of all, let's take a look at the first atom. The first atom is having 2 electrons in the first shell or the first orbit and 4 electrons in the second shell. So how do we write its electronic configuration? 2, 4, right? So let's write that down. The electronic configuration is 2, 4 here. And what is the electronic configuration of this guy? It has 2 in the first shell. So let's write that. And comma, how many in the second shell? 1, 2, 3, 4, 5, 6, 7, 8 here. 8 in the second shell. So you can see both the atoms are having 2 shells, but one is having 2 plus 4, 6 electrons. This guy is having 2 plus 8, 10. And they are arranged according to Bohr-Berry's rules, right? So these electrons are arranged in accordance to certain rules which are known as Bohr-Berry's rules. Now, which atom is stable? We can easily tell the answer by looking at the last shell, the outermost shell. So if the atom is having only one shell and it has 2 electrons in the outermost shell, then it is stable. This is called duplet rule. So only one shell, I repeat, and 2 electrons in that shell, because you know the first shell can have only 2 electrons, maximum of 2. So if it has 2 electrons, it is stable. That is called duplet rule. But here you can see it is having more than one shell. It has 2 shells. So now we look at the outermost shell, and if it has 8 electrons in the outermost shell, then it is stable. That is known as the octet rule. So based on the octet rule, which one is stable? Definitely it's going to be this guy, because this is having that magic number of 8 electrons. So we can see it is following the octet rule. So which atom is stable? Clearly you can see the one on the right. This guy is stable because of its electronic configuration. Note, we still haven't identified, or maybe you guys have guessed which atom it is, but just based on how the electrons are arranged in the atom, the electronic configuration, we can tell which one is stable. Clearly this one, because it is following octet. Here we can't apply duplet rule, because duplet rule says only one shell and 2 electrons in it. Here they have 2 shells. Now can you guys identify these atoms for me? Which one are these? So who's this guy? The guy on your left is basically carbon, 2, 4, 6 electrons. So very good, this guy is carbon. And who is this guy? 2 plus 8, 10 electrons, atomic number 10. It is basically the noble gas neon. This is the noble gas neon. And we know all inert or noble gases are stable, and it is stable because of the octet rule. So in summary, the rule of stability says that atom is stable if it follows the duplet rule, which basically means one shell and having 2 electrons, right? So if the atom has only one shell and has 2 electrons, and who is that guy who has one shell and 2 electrons? It's the helium gas, again the noble gas, right? So this is basically the duplet rule. And this one, if it has more than one shell, then you only have to look at the outermost shell. If the outermost shell is completely filled up with 8 electrons, because the outermost shell can have maximum 8, the magic number is 8. Like in Harry Potter, the magic number is 7. 7 Harry Potter books, 7 Horcruxes, right? Here the magic number is 8, unless you're following duplet. So here you can see the outermost shell is having 8 electrons. So we say outermost shell or valence shell. And it's called octet rule because octopus has 8 legs, similarly octet. And in the duplet rule, one shell with 2 electrons, because you can see the first shell can have maximum of only 2 electrons. So this is how you apply the rule of stability. So we know that atoms form bonds for stability, to become stable. And we'll see how they do that, because if they do not have the duplet or octet, then they will, gain, lose or share electrons. So they will form these chemical bonds. But chemical bonds are of different types. Okay, the bonds are not of the same type. So here you have, just like in life also, in relationships, you have brother, sister, you have cousin, you have friends, husband, wife. Same way over here you can see bonds in atoms are not only one type. You have ionic bond, covalent bond, coordinate bond, different types of bonds. And we'll see what is the difference in these chemical bonds. But again, the atoms are doing it for their stability. So these are the 3 types of chemical bonds. In today's class, we will be focused on ionic and covalent. Coordinate bond, which is there in the ICSE syllabus, I'll be covering in the separate class. Okay, so today's class will be focused on ionic and covalent. Now the question is, what is the difference here in the bonding type? So in ionic bonds, these are also known as electrovalent bonds. So let's write them down. So the other name for ionic is electrovalent. So in ionic or electrovalent bonds, these involve the transfer of electrons, which means if 2 atoms, they want to form a bond, there will be a transfer of electrons from one atom to the other. So it's like, you give your friend a chocolate, let's say you want to make somebody a friend, you give them a chocolate and say, will you be my friend? Same way over here, the one atom is transferring the electrons to the other atoms and they are becoming friends. They are having this bond. So here we can say in ionic bond, there is a transfer of electrons. And when there is a transfer of electrons, because electrons are negatively charged particles, so let's say you transfer electrons to your friend, then what happens? Your friend will gain more, has more electrons, so he becomes negatively charged, and you have lost electrons, so you become positively. And positive, negative attract each other. So you can see, because there's transfer of electrons, ions are formed, and you know that there is an attractive force. So that is why it is called ionic bond, because it is when there is a transfer of electrons, ions are formed, cation and anion. And we'll be looking at the details of this. Next one is covalent bond. So just like you can make friends by giving a chocolate, you can also make friends by sharing a chocolate. So let's say you take a chocolate to your school and you share it with a friend, and he or she becomes your best friend. So same way over here, covalent bonds, here of course there are no chocolates. Covalent bonds involve sharing of electrons, because atoms are all dealing with their electrons. Protons, neutrons, they are all in the nucleus. So always sharing is with electrons. So here we can say covalent bond involves sharing of electrons. So now when electrons are shared, ions are not formed because there's no real transfer, so there's no positive, negative or cation, anion happening. So here it was called ionic bond. These are called covalent bonds, but what is formed as a result of it? Molecules. So another word for covalent bond is also called molecular bond. So let's write that down. Covalent or molecular bonds. So these mean the same thing. And the last one is coordinate bond. Another name for coordinate is also called dative bond. So the difference here is, so when I was mentioning the covalent or molecular example, molecular bond, let's say you're making friends when you take a chocolate and your friend also takes a chocolate. So that is the real sharing. Just we say sharing is caring, right? So you are not just giving the chocolate, your friend has also brought a chocolate for you. So you are sharing the chocolate and then eating it during your lunch break, right? So that is really covalent or molecular bonding. But in coordinate or dative bonding, what is happening? The chocolate, one friend is giving it to the other or sharing it with the other, but the other person is not, right? The chocolate is being shared only by one person, or the electrons here are being shared only by one atom. Here both the atoms are sharing electrons to form covalent bond. Here the sharing is done only by one atom. So the important difference here is that the shared pair of electrons comes from just one atom. Okay, but here both the atoms are sharing electrons, 1, 2 or 3 or whatever, but here it's only coming from one. So that is the difference here. Again, in today's class we'll be focused on ionic and covalent bonds. So now let's dive into the details of ionic or electrovalent bond. Same thing, right? Ionic is an easier word, easy to remember, than ions are formed. So let's say there are these two atoms. Okay, remember in ionic bonding, what did I tell you? You are giving a chocolate. There's no sharing. You're not eating it together. You are just giving a chocolate to a friend and you become friends with them, right? So you're being generous and you give the chocolate. So let's see here how the chocolate or the electron is being transferred and why they are transferring it. So let's say you have these two atoms. Okay, even if you don't know the atoms, doesn't matter. Let's write down their electronic configurations based on this diagram. So what is the electronic configuration of this atom? You can see 2, then 8 in this next shell and 1 in the last shell. So it's basically 2, 8, 1. And what is the electron configuration of this guy here? 2, then you have 8 electrons, and then 1, 2, 3, 4, 5, 6, 7. So let's write it down. It's going to be 2, 8, 7. So are these atoms stable? For stability, remember I said if they have more than one shell, you have to look at the last shell, right? So outermost shell is having only one electron. This guy is not stable because he is not following octet rule. You can't say, oh, there's a 8 here. No, you have to look at the last shell, the valence shell. Same way over here, 2, 8, 7. Is this guy stable? No, because he's having 7 electrons in the valence shell. For stability, you need 8, and this guy has 1. So how will these guys get stability? So all of you agree that both these atoms are unstable because obviously they are not following duplet rule. They have 3 shells and they are not following octet also. Octet means last shell should have 8 electrons for stability. So now these two friends, or trying to be friends, guys say, how do we become stable? So this guy says, okay, I am 2, 8 and 1 electron. How about if I lose that last electron? Or another option is he needs 7 more. So to get 7 electrons, he'll have to contact, 7 friends or 7 people or, more people. So he says, rather than doing that, I'm going to be smart and give away my last electron, the valence electron. Because if he gives it away, he's going to become 2, 8. Do you guys agree? If this guy gives away his electron, he's going to be 2, 8. 8 means stable, octet. And this guy says, hey, I have 2, 8, 7 electrons. So for me to become stable, either I have to give away all 7 electrons, which means I have to find people to receive these 7 electrons, or I can just gain 1 more. So again, he's also smart, finds the easy way, just like we find shortcuts. He says, if I just get 1 more electron, I'll become 2, 8, 8. Hooray, I'll become the octet. So what is going to happen here? This guy is going to, he wants to lose an electron, and this guy wants to gain an electron. So can you see what's happening here? There is going to be a transfer of electron. Okay, so if this guy transfers the electron, then this electron is gone. So this, he loses the electron and he gains it. So when he loses this electron, what happens here? So by losing an electron, this guy is going to become 2, 8. And by gaining an electron, he is going to become 2, 8, 8. So here rather I can write it as, so there you see, both these guys are happy. He has become stable. He has also become stable by octet rule because they are having 8 electrons in the valence shell. So they are happy. Both are stable. And by losing an electron, and this guy by gaining that same electron. Okay. But when you lose an electron, what has this atom become? Because remember one very important chemistry concept, all atoms are neutral, no charge, because the protons, electrons are equal in number and opposite in charge, they cancel each other. So all atoms in the world are neutral. But when he loses an electron, what is going to happen to this guy? He is going to become positively charged. He will become a cation. And this guy, on gaining the electron, he becomes negatively charged. He becomes an anion. Cation is positive, anion is negative. Positive, negative attract each other. Just like North Pole, South Pole of a magnet attract. Positive and negative charges, unlike charges, attract each other. So it forms a ionic bond, attraction. There is a force of attraction here because this guy is positive, this guy is negative. So till now we have not identified these guys, right? We have just been talking in terms of electrons and atoms. So let's take a look who these guys are. So in this example, this is 2, 8, 1, atomic number 11. Who is it? It's the atom sodium. So this was sodium atom, and when sodium loses an electron, so sodium on losing the electron becomes the sodium cation. And we know metals like to lose electron because they have only 1, 2 or 3 valence electrons. They want to lose it and become stable. And who is this guy? 2, 8, 7, which means atomic number 17. This is nothing but chlorine atom. Chlorine atom on gaining an electron becomes chloride ion. So what you're looking here on this board, you have sodium chloride. You've seen sodium chloride, it's the salt that we eat every day. So it is formed by the combination of sodium cation and chloride anion. So when this sodium cation and chloride anion attract each other, we have our ionic bond. As simple as that. And both these guys are happy because they have got to a stable state. So it is all happening due to, the key thing is, in ionic or electrovalent bond, there is an actual transfer of electron. Now there could be a transfer of 2, 3, it could be more as well, but in this case there's a transfer of 1 electron, and we have formed our sodium chloride compound. So many times when you have to show the electron dot structure, sometimes it will be saying, the question will be, show the bonding, for example here, between sodium and chlorine, between sodium chloride, if you want to show the bonding. So here we know that this is the sodium atom and this is the chlorine atom. Now if you want to show the bonding diagram, how do we express the bonding? So usually in the bonding we don't have to draw all this structure and show the transfer. The simpler way is, because who's the key thing over here? Is it all the electrons or only the valence electrons? So in bonding it is usually the outermost, the valence electrons which are involved. So we don't have to bother about all the electrons. What we are going to do is show only the outermost electrons. So please do that. So how we are going to express this? We are going to draw sodium, and outermost it has only 1 electron. So we are going to draw that here. And then it's combining with chlorine, which is having 7 electrons. There you go. Okay. So when these guys combine, what is going to happen? There is going to be a transfer of electron. So you can draw an arrow over there. So we are just drawing the electrons of the valence shell. And usually in electron dot structure, what do? We draw the atom, the electrons on one atom with dots, the other one with cross, so that we can differentiate between the electrons. You can use dots on both if you want, or if in your school they're doing that, but usually one atom you show dot, the other one with crosses, but both are representing electrons. Here there's 1 electron, and here in the outermost shell there are 7 electrons. Can you see I've represented the 7? So now when this transfer of electron happens, what is the next step? Because sodium loses the electron, it's going to become sodium ion. So we are going to write Na plus, and usually for the ion we put these box brackets around it. Because it has lost the electron, we mark it as Na plus with the box bracket. And who's this guy? Chlorine has gained an electron, so what does it become? So you draw chlorine with its 7 electrons. So the original 7 electrons, and then it has gained 1 more electron here. So once again we put the box brackets and we put the minus sign here. So minus sign you can put inside or outside depending on how it's shown in your school. So in some of the books it's drawn outside as well. So there you can see we have shown the bonding of sodium chloride. And then if you want, you can even write this as further one more step. Na plus Cl minus, which is nothing but your compound NaCl. So this is called, if they ask you the question, show the bonding between sodium and chlorine or between any other two compounds, then this is how you show it, right? By the transfer of electrons. Okay, and this is the bonding diagram. Now one important thing here, that when are ionic bonds usually formed? Ionic bonds involve transfer of electrons. So when will there be a tendency of transfer of electron? If one guy is ready to give away the electron and one guy is ready to accept it, right? So suppose one friend wants to give the chocolate and the other one wants to receive it. If one guy doesn't want to give or the other guy doesn't want to receive, you will not have an ionic bond. So when does this happen? Ionic bonds are usually formed when there is a metal and non-metal involved. So this is very important thing, because metals they have the tendency to lose electrons. They have only 1, 2 or 3 electrons in the valence shell. And non-metals, they have 4, 5, 6 or 7 electrons in the valence shell. So they have tendency to gain to complete the octet. So this is an important point, that usually ionic bonds are formed between the metals and non-metals. So you can remember this note here, usually formed between metals and non-metals, because metals tend to give away electrons, non-metals tend to receive the electron. Let's also try the bonding between magnesium and chlorine when it forms magnesium chloride. Again, you can see here, magnesium is a metal. Magnesium is a metal. Chlorine guy is a non-metal. So metal and non-metal will tend to form ionic bond or electrovalent bond. So we can see here that when metal and non-metal combine, you will have an ionic bond. Always, before drawing the bonding diagram, you need to ask yourself that question. Is it ionic or covalent? Ionic involves transfer of electrons and it happens between metal and non-metal. Covalent, as we are going to see, usually happens between two non-metals. So the simple James Bond rule is, if there is a metal, non-metal, ionic bond. If there are two non-metals, covalent bond. So let's try to draw the bonding diagram here. So again, in the bonding diagram, you don't have to draw all the entire shells, just the valence shell, the outermost shell. So for magnesium, we know magnesium is basically having atomic number 12. So the electron configuration is 2, 8, 2. And chlorine, as we saw, has electron configuration 2, 8, 7. So first let's draw the magnesium structure. So magnesium is having 2 electrons in its valence shell, as you can see here. Chlorine has 7. So magnesium wants to give away how many electrons to become stable? It wants to give away 2 electrons so that it becomes 2, 8. But the problem is chlorine wants only 1. So what do you think is going to happen here? Magnesium wants to give 2, chlorine wants only 1 electron. So how will they form the bond? Otherwise there's going to be a fight here. So what is the solution here? So another nice James Bond trick is, before you draw the diagram, first you think what is the formula of the compound. So if you think magnesium and chlorine, just by valency we know magnesium has valency 2, chlorine is 1. So if you guys do the crisscross, we are getting MgCl2, right? So we know that magnesium chloride molecule, or when it forms the compound magnesium chloride, it is having 2 chlorine. So 1 chlorine is not enough, we need 2 chlorine atoms here. So what we are going to do, we are going to draw another chlorine atom. Now you can transfer the electrons, because this electron goes here and the other electron goes to the second chlorine atom. Now there is no problem, because both the chlorines want only 1 electron and magnesium has 2, there are 2 chlorine atoms. So this is how you draw the structure. And finally, what are we going to get? When they combine, magnesium has lost both its electrons, so it has become magnesium 2 plus ion, the magnesium cation, and chlorine, each of the atoms have gained 1 electron, so it has become chloride minus, negative. Now rather than drawing 2 chloride ions, you can simply, and please don't write the 2 here, that is what is written in the formula MgCl2. The 2 by convention is actually written here. So this shows 1 magnesium cation and 2 chloride anions. So this is forming magnesium chloride, so we can write it as MgCl2. So this is how you show the bonding structure. So the simple tips and tricks here are, before you start drawing the bonding diagram, first think, is it ionic or covalent? The simple rule is ionic is formed between metal and non-metal. Covalent bonds are formed between two non-metals. So here it will be ionic. Then before you start drawing the bonding diagram, first thing, what is the formula? We know the formula is MgCl2. So that means I need 1 magnesium atom, 2 chlorine atoms. So you draw it like that. Show the transfer of the electrons with the arrows, and it's always good to put, dots for electrons on one atom and crosses for the other. When you show the transfer, now you show the ions and your ionic bond. So isn't this simple and easy now? Next, let's look at covalent bonds. What did we say in covalent bonds? In ionic bond, there's transfer of electron. Covalent bond involves sharing of electrons. Let's see why. So for example, you have these two atoms, and these atoms are very simple. They have only 1 electron. So you guys can guess who is this? Atom which has only 1 electron and 1 shell. Simplest atom in the universe, it is hydrogen, right? So what we are looking over here is hydrogen atoms. Now both these hydrogen atoms, they say to become stable, I want 1 more electron. So this guy says I want 1 more to get to duplet. because I have only one shell. This guy and one electron. He says, I also have only one electron. I want one more. So he says, you give me the electron. He says, you give me the electron. So there's a fight happening here. But the simple resolution of the fight is, their mom comes and tells them, why are you fighting for the electron? Please share the electron. Just like, moms tell two siblings, why are you fighting over the chocolate? Share the chocolate. Same way the mom is going to say, share these electrons. So that's it. When they start sharing, so when these two share the electrons, that means this electron is also ready for this atom and this electron is revolving around this atom. So now both are happy because both have got 2 electrons each, and so they have formed their duplet. So how we can draw this or represent this? You can imagine it like this. Here is one hydrogen atom with an electron, and then you draw another hydrogen atom having an electron. So can you see both are sharing it? So these 2 electrons belong to this guy as well as to this guy. They have formed a covalent bond between these 2 atoms. So is this clear to you? So now we can, and when we draw these 2 atoms, right, when we represent the bond, the covalent bond is represented with a single line or a simple line. So we say this is the bond and they have formed the H2, the hydrogen molecule. So this dashed line is representing the covalent bond between these 2 atoms. Is this clear? Now how do you draw the bonding diagram? Simple. You just represent, let's say, one hydrogen atom. It is having one electron. Then it's trying to combine with another one. Now since these atoms are the same, we can represent the dot in both, right, rather than dot and cross. So what happens is these 2 guys come near to each other and they end up sharing 1 electron each. So you have a shared pair of electrons. So both are having 2 electrons, they are following duplet, they are happy and stable, and they have formed the hydrogen, the covalent bond between the hydrogen atoms, which gives rise to your H2. So this is how you represent it in chemistry. Sometimes you'll see in the books, they also draw these to show that these 2 electrons are belonging to hydrogen. You'll see these kind of circles here, and you can draw another circle this. So there you can see both the hydrogen atoms are having these 2 electrons. This looks more like a Venn diagram if you guys have done sets and Venn diagrams. So it is showing that both the hydrogen atoms are having 2 electrons each and they are following the duplet. So this is known as a shared pair of electrons. So what we have shown over here is a shared pair of electrons. And this dashed line is nothing but a covalent bond, and we call it a single covalent bond because there is one shared pair of electrons. So can you see here? One shared pair of electrons. Why pair of electrons? Because there are 2 electrons, one coming from each atom. So please remember, in covalent bonding, both atoms are contributing to to the shared pair. In coordinate bond, which we're not going to do in today's class, only one atom gives the shared pair, the other one doesn't, right? So here both the atoms are contributing 1 electron, and that is forming your covalent bond, and both these hydrogen atoms now become stable. Now you can see why hydrogen is a diatomic gas, why it is forming the H2 molecule. Can you guys see? Because a single atom is very unstable. It wants to react with itself or somebody else. That is why hydrogen is forming the hydrogen molecule, the diatomic molecule. Let's try another example of covalent bonding, which again means sharing of electrons. So here you can see we have 2 atoms having 2,6 electrons. So who are these guys? This is having 2,6 electrons and this one as well. So these are identical atoms. So these atoms are nothing but oxygen, because we know oxygen has atomic number 8, 2 plus 6 electrons. So now these guys say, I want to be stable by, I need 2 more electrons to become stable, because 2,6 is not stable. So what do these guys decide to do? Again, both of them are fighting. They want 2 more electrons. So their mom tells them, why are you guys fighting? Why don't you share 2 electrons each? So why don't you share 2 electrons each. So this guy will get 2, this guy will also get 2. So he'll have 2 with him, he'll also get 2 with him. So sharing means the electrons are revolving around both the atoms. So this is how they are forming a bond. So this will end up looking something like this, right? So oxygen, both of them are sharing 2 electrons. So you can see both of them will have ultimately 8 electrons. So how do you draw the electron dot structure of this? How are you guys going to draw this? So if you guys draw the electron dot structure, it's going to look something like this. So the bonding diagram, oxygen having 6 electrons, this oxygen atom also having 6 electrons. And we draw the electrons in pairs. And remember, since they are sharing it, so we keep these 2 electrons ready for sharing with this guy and these 2 here on this side. So don't draw the electrons this side, draw them as if they're ready for sharing, okay? Because these 2 are going to be shared. So when they come close to each other and share the electrons, the diagram is going to look something like this. So there you go. And again, you can draw the circles to represent, has the octet been completed. So there you can see this oxygen is having 8 electrons. This oxygen is also having 8 electrons here. So both are having their octet. So finally, what do we get? As a result of this, both the oxygen atoms are sharing how many electrons? 2 pairs of electrons. And every dash or every line represents 1 shared pair. So since you have 2 shared pairs here, we are going to draw 2 lines. So this looks like, a pair of glasses here or something. So, but these 2 lines are representing 2 shared pair or 2 covalent bonds. And that's how you get your O2 molecule. So please understand what you have over here. What is this? This is a double covalent bond because there are 2 shared pairs. So what we have over here is a double covalent bond. In hydrogen, you had a single covalent bond. Here you have a double covalent bond. Is this crystal clear? And this is how you show the bonding diagram. Let's look at the nitrogen molecule. So in nitrogen, again we know nitrogen is diatomic N2. So how is the bond formed? So nitrogen atom is actually containing 2,5. Its electron configuration, it has 7 electrons. So 2,5. So let's draw the electron configuration. Again, we are going to show only the valence shell. You don't have to show all the shells, right? So in the bonding diagram, you just draw nitrogen and we are going to draw 2 electrons, then 2 here and then 1 here. So same way when we draw 2, 2 here and then 1 here. Now we know in nitrogen, to gain stability, how many more does it need? 3 more. Because 2,5, it needs 3 more to become 2,8. The last shell needs 3 more. That means nitrogen wants to share 3 electrons with the other guy. So you have to modify this diagram a little bit because we want to share 3 electrons. So we are doing an exception over here. Rather than drawing it in pairs and this single electron, we are going to draw a triplet over here. Because again I said they should be ready for sharing. So you have to keep them ready for sharing like this. So what does the diagram look like now? When they come close to each other, the 2 nitrogen atoms are going to look like this. So there you can see, if you draw these circles, this guy is having 8 electrons and same way this guy has 8 electrons as well. There you go. So both have got their octet, both are happy and stable. And so what does our bond look like? How many shared pairs do we have? 1, 2, 3. There are 6 electrons, 3 shared pairs. So we need to draw 3 bonds. 1, 2, 3. And then finally we represent the molecule N2. So nitrogen is containing a triple covalent bond. There are 3 bonds, right? So this is nothing but a triple covalent bond. That is the nitrogen molecule. Clear? So this is how you represent it. And so the difference you saw there, sometimes it can be single covalent, double covalent, triple covalent. Every line, this line represents a shared pair of electrons, and in shared pair, 1 electron. In every shared pair, 1 electron is coming from each of the atoms. So yeah, this is an interesting question, that Why this is not N3? This is a triple covalent bond, but how many atoms are there? 2 atoms. So the formula is N2. It is a diatomic molecule, not triatomic. How about water molecule? So water molecule is formed between hydrogen and oxygen. So what type of bond will it be? Water we know is H2O. So compound formed between hydrogen and oxygen. Hydrogen is a non-metal, it's a gas. Oxygen is a non-metal. Non-metal, non-metal, covalent bond. So water molecule involves 2 non-metals. Non-metal plus non-metal will obviously result in a covalent bond. Yes? So how do we represent this? Please try it out. So we are going to draw, so we know in water, so rather than starting with all the diagrams, another interesting trick is you can think in terms of valency. Oxygen has valency 2, hydrogen has valency 1. Since oxygen has valency 2, that means 2 bonds it can have with hydrogen atoms. So the water molecule structure is going to look something like this. See, oxygen can have 2 bonds or 2 lines. Hydrogen has valency 1, so only 1 line, 1 bond. So we know the structure is going to look like this. Now you can backtrack and arrange the atoms like this. So we are going to draw 1 hydrogen atom having 1 electron, oxygen atom with 6 electrons, but 1 here on each side so that it's ready for sharing. And now the sharing is between hydrogen and oxygen. So when you guys draw this, and again see I've drawn dots for hydrogen and cross for oxygen. So when you bring them together, so hydrogen, oxygen, there you see this is how the sharing is going to look like, which will result in this sort of bond, and so the final molecule is H2O. And once again, if you guys draw these circles to see, there you can see hydrogen is getting its duplets, oxygen is getting its octet over here. There you go. If you look at the methane molecule, how does the methane molecule look like? So methane is involving carbon and hydrogen, so it is CH4. Carbon has valency of 4, so we know carbon can have 4 bonds around each other, so around itself, and hydrogen can have only 1 bond. So we know the structure is going to look like this. So please go ahead and draw the atoms with their valence electrons. So carbon is going to have 4 valence electrons and hydrogen has 1. But we know that we need 4 hydrogens. So we are going to write 4 times H. So rather than drawing 4H, you can simply write 4 times H. So what is the structure going to look like? So you put carbon in the center and surround it with 4 hydrogens. So there you can see we have our bonds, and this is what methane is going to look like, which is containing 4 single covalent bonds. So final formula is methane, CH4. And here again you can show the circles to show the octet and duplets. Again happening due to sharing of electrons, methane will again form covalent bond. Why? 2 non-metals. Carbon is a non-metal, hydrogen is a non-metal, so we know this is not going to be an ionic bond. So what are the difference between properties of ionic and covalent compounds? So we know that ionic compounds contain ions, so the particles are ions. Because the force of attraction between cation and anion is very high, so they are usually hard solids having high melting and boiling points. And they are also good conductors in molten or aqueous state due to the presence of ions. So molten means liquid state, so when you heat it, and aqueous means when dissolved in water. So due to the presence of ions, ionic compounds are good conductors of electricity. They are also soluble in water. So these ionic compounds easily get broken down in water, and they are soluble in water, but they are insoluble in the organic solvents. Organic solvents means compounds like alcohol or benzene, toluene. These are all considered organic solvents. And covalent compounds, they are the opposite. These particles, they contain molecules, not ions. And because the force of because the covalent bond is weaker, so here there's strong electrostatic force between ions, but here the force is not that strong. So they are usually gases, liquids or soft solids having low melting and boiling points. So you can see they are sort of opposite to each other. And since there are no ions, these guys are non-conductors in solid, molten or aqueous state. And they tend to be insoluble in water, but they are soluble in the organic solvents. So here you can see these differences, and you can easily understand these differences based on the bond that we have seen, right? The ionic bonds are formed from ions, whereas covalent compounds are formed usually by sharing of electrons. So they end up having particles, having molecules, not ions. What type of bond is present in hydrogen chloride? What do you guys think? So again, be the James Bond here. Hydrogen chloride is a compound containing hydrogen and chlorine. So we know hydrogen and chlorine. Hydrogen is a non-metal. Chlorine is a non-metal. So what type of bond they'll form? Obviously they'll form a covalent bond. And hydrogen has valency 1, chlorine has valency 1. So they end up forming a single covalent bond by sharing one electron. So the correct answer here is single covalent bond. So hope you guys enjoyed this class where we looked at ionic and covalent bonds. So these were the two important types. Coordinate is also there, but that's not in the scope of today's class. That will be done in a separate video. So we have learned about the different types of bonding, and ionic and covalent in particular. This is due to transfer of electrons. This is by sharing of electrons. So hope you guys are now the James Bond of chemical bonding. And do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other subjects, do take them and do share it out with your friends. For the ICC students, once again, we have physics, chemistry, biology and maths for classes 8, 9 and 10. So do share out our courses. And if you want to learn coding, we have Python programming, we have Java coding. Both are great languages to learn computer programming. And we have physics and chemistry for the Cambridge IGCSE, which is the international board. So do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected with Manocha Academy and keep learning.